Okay, what we're going to talk about now is the concentration of solutions. Concentration just refers to how much solute is dissolved in either a given quantity of solvent or a quantity of solution. Okay. The easiest, most common way I can think of how to describe concentration in everyday terms is like Kool-Aid. When you're making Kool-Aid, the more Kool-Aid powder you put into a given amount of water, the stronger the Kool-Aid is going to be. If you look at these pictures here, we can assume this one is not very concentrated, while this one has a lot of solute in it. And this we can just tell by the color. When you look at this picture, it's talking specifically about the number of particles. So this one, there's no particles in it. Here we have one particle, so this we assume would be a weak concentrated solution. And this one here with a lot of particles in it, a lot of solute, would be a highly concentrated solution. This one will probably be dark. The most common unit of concentration that we use in chemistry is called molarity. The symbol for molarity is a capital M, and it's just the way we measure the concentration. It's the number of moles of solute in a liter of solution. So molarity is moles per volume of solution, specifically per liter of solution. Okay, the formula is going to be capital M for molarity equals moles over V. And so the volume is going to be in liters. Okay? So let's do a practice problem. It says calculate the molarity of a solution made by dissolving 23.4 grams of sodium sulfate in enough water to form 125 milliliters of solution. Okay? So we write our formula first. I always recommend writing the formula first so you can tell what you have and what you need. So remember, capital M molarity is equal to moles over liters. Now I'm given milliliters of solution, so I need to change that to liters first thing. 125 milliliters. There's 1,000 milliliters in 1 liter. So that's going to be equal to 0.125 liters. Okay, so now we have liters. The next thing we need is moles, but I'm given grams. So we're going to have to change the grams to moles. Okay, first of all, sodium sulfate is Na2SO4. So since I'm given grams and I need to go to moles, I need to look at my periodic table for the molar mass. I already did this on the side, so hopefully you guys still remember how to do this. And it's 142.046 grams is equal to 1 mole. Grams and grams cancel out. When I multiply across, I get 0.165 moles. Okay, so now I've calculated the moles. So I have 0.165, going back to our original equation, over 0.125. This is mole per liter. And that's equal to molarity. Okay. When you calculate this out, the answer happens to be 1.32. And the capital M, in this case, when we're using it as a unit, it's referred to as molar. So 1.32 molar sodium sulfate. This is a simple equation, so using basic algebra skills, you should be able to convert between any three of these variables, given that you have the other two. For example, we know capital M is molarity is equal to moles over volume. If we are given molarity and volume and we're looking for moles, that means we need to solve for moles, so we need to get moles by itself. So we multiply by volume. Volume cancels out. What we do to one side, we do to the other. So the molarity times the volume will give you moles. And if you look at the units, that should make sense because molarity is moles per liter. We know the volume must be measured in liters. Oops, it should say mole. So when you multiply molarity times liters, liters will cancel out and you're left with moles. Okay? Similarly, if we're given molarity and moles and we're looking for volume, you should be able to solve for that as well. Okay. So this time it's a matter of getting volume by itself. Since volume is on the bottom right now, we need to get it to the top. So we multiply by volume. Volume and volume cancel out. What you do to one side, you do to the other. So we get molarity times volume equals mole. But I need volume by itself. So now I divide by molarity, divide by molarity. So the volume is equal to moles divided by molarity. These should be easy manipulations for you at this point. So we'll do one practice example. A solution of HNO3, so since the H is in the front, it is an acid. NO3 refers to the polyatomic ion nitrate. When it's an acid, it now becomes nitric acid. So a solution of nitric acid has a concentration of 0.200 molar. How many moles does a 2.0 liter solution contain? So always start with the basic formula. So this time we're given liters and we're given a molarity, so we're looking for moles. So I know moles times liters. Sorry, I put the L and I should be putting V for volume. So the molarity is 0.200 molar, and molar is the same as moles per liter. Okay. So this is this. Okay. And then I'm going to be multiplying by the amount of volume I have, which is 2.0 liters. And that's how many moles I'm going to have. So liters and liters cancel, and then I just multiply. 0.200 times 2 is 0.400, and it's going to be moles. So you need 0.400 moles of nitric acid in 2 liters to get a concentration of 0.200 molar.